So in this first module, we're going to go over how to set up a real-time system. So by the end of this first training, you're going to have a real-time system to do RTX development on. So there's three basic portions to this training. First, we're going to have a quick 3-minute introduction to RTX. Then we're going to go through the installation and configuration, and then finally we're going to validate the system. So let's go ahead and start with a quick 3-minute introduction to RTX. So in the next couple minutes, we're just going to talk about how RTX transforms Windows into a real-time operating system. Here we have a dual-core x86 platform, and here you have the Windows operating system. So this should look pretty standard. We have the Windows hardware abstraction layer here. Here's the kernel and scheduler. Here we're crossing into the user mode. This is where the subsystem is, the Win32 APIs, and then the application up above. Okay, so when you install RTX onto a system like this, what happens is now you can still use the dual cores, but you can dedicate one core for Windows and one core for RTX. And now you can have all real-time processing executing on this one dedicated core. So now here's the RTX HAL. So we extend the Windows HAL. We don't alter it or modify it in any way. So this what allows us to have direct interaction, and we also have ability to have up to 1 microsecond timer resolutions. So that's truly, very deterministic interaction. And then if you put a layer on top of that, RTX, here's the scheduler. So we have the RTX subsystem here. It's all Win32 based, and we have processor affinities. So you can assign the routines to run on, this is one core here, but RTX 32-bit supports up to 31 real-time cores. So we could essentially have 31 cores where you can specifically assign which core you want your real-time functions to execute on. Okay, and so now we move up from the subsystem. Here we have real-time processes. So this is where your real-time applications exist, and you can also create real-time drivers. So with the real-time drivers in RTX, you don't have to follow any complex driver model. You can essentially create the drivers to have direct access to the hardware, for example, your PCI bus. So now, for example, you might be asking, here's your real-time applications, here's your Windows applications. How do we communicate between them? Well, one of the things we do is we have an API set that is exported into the Windows side of things in the user space. So you'll have a whole set of APIs here that you can use to control and synchronize based on events, semaphores, your Windows application with RTX. Okay, and also I should mention, so while you link against this library in Windows, here in RTX you're going to be building in the same environment as you do your Windows applications. So you're going to be using Visual Studio to build and debug all of your applications, both non-real-time and real-time. Okay, and finally for the data communication, so you're using this RT API or real-time API set to do the synchronization. For the data, we're going to use shared memory. So you have this unified shared memory space to basically say I want data moving from Windows to RTX or vice versa, RTX to Windows. So that summarizes how RTX transforms Windows into a real-time operating system. So now that you have a good overview of RTX, the next thing we're going to go into is installation and configuration of RTX. So let's go ahead and get started.
So once you've downloaded RTX 2012 and open up the folder, you'll see a number of different files here. First you'll have a couple of PDF files, including the installation guide, and you'll have the setup file, and then we also include a .NET Framework 4.0. So this is required for some of the user interfaces. So just in case you don't have it, we provide it for you here as well. So just in case you didn't know, so I'll be installing this over the internet, and so if you have any sort of different type of configuration, definitely take a look at the installation guide, and they have all the different types of scenarios how you might activate the product, and I think it's a very helpful document. So let's go ahead and start the installation. And here we're gonna start the process, and just to speed things along, you might see me time-elapse some of this installation, but overall the whole thing shouldn't take more than a couple minutes. And also, just to point out, you definitely want to be installing as an administrator, so that allows full permissions to install this package onto your system. So here we have the first welcome screen for the installer, and here's another way you can get to the installation guide. Again, this is a great document just to explain all the different methods on how you can activate the product. I'll be activating over the internet, but you might want to activate your product, via a USB key. So if you go through this document, it will show you all the details and, for example, the specific website you need to go to do the file exchange to get your license key. So anything that may deviate, from what you might see here, definitely check the installation guide for more details. So let's go ahead and click next. And we're going to go ahead and accept. These are the end user license agreements, so you can read through this if you like. And then click next here. Here's just some of your information you can put in. Click next. Here's the destination folder. So we're going to take the default, but you can change that if you'd like. And here are the different components, so you can control what components you want installed on the system. In our case, we want everything, but some people might not want to put the runtime or the subsystem on there, so you can deselect this and just install, for example, the build tools. We're going to leave everything the way it is. Click next. We're going to want desktop icons and start menu icons, and we'll start the process. So again, I'm going to fast forward through some of this just to move things along a little bit. So one thing I want to point out is while the installation is taking place, some of the things that are going on in the background is, user group policies are being updated for the right permissions to interact with Interval Zero's RTX. Okay, and we'll go ahead and click Install Trust from Interval Zero. Okay, so that's it. So the installation is complete. We'll go ahead and click Finish. And next, what you'll see pop up is the activation and configuration utility. So here, you're going to now go back to the email that you received from Interval Zero. And if you look down below here, here's the activation key. So we're going to go ahead and copy this. And we're going to come back to the activation utility, and we're going to paste it here and click Activate. Okay, and you can see that the activation was successful, and if you look at the window down here below, you can see a list of components that were successfully licensed. So we have the RTX subsystem, the real-time TCP/IP stack, and the software development kit. And you can see here under the RTX subsystem, it's not configured. So we're now going to want to configure it. So let's go ahead and click this button here, and if you see here, I'll just mention this is a standard Dell laptop, and it's a quad-core machine, so nothing really special, pretty standard off-the-shelf hardware. And if you look here, here's a graphical representation of the different cores inside of here. So we have 4 cores, and by default, when you install RTX, 1 core gets dedicated for Windows, and then the remaining usually go to RTX. So, and of course, this depends on what edition of RTX you have. I have the Ultimate Edition here, so this means that I have support up to 31 real-time cores. So by default here, I have only 3 remaining. These 3 will be dedicated for real-time under RTX. So you can change this if you'd like. You can see here I can change to have 3 Windows and 1 RTX, and then go back and I can split them. So you can just click on the graphics or enter the number into the dialog boxes. But we're going to leave it to where it's 1 for Windows and 3 for RTX just for simplicity. And we're going to go ahead and click Done. And then what you'll get here is just a prompt to restart the machine. So whenever you do any sort of processor configuration changes, you're going to have to reboot. So this is our first time after the install. So once we reboot, you're going to have a new boot option that will allow you to have just Windows running or Windows and RTX. So you will have 2 selections during boot time. So let's go ahead and restart the computer and continue on to the next section.
So now that we've downloaded RTX, we've installed and activated it, and we've configured the processors, we're now ready for the next and final stage, and that's to validate your system. So to do that, we're going to use a tool that comes with the installation called Platform Evaluator. So let's go ahead and get started with that.
Okay, so now that we've rebooted, let's go ahead and launch our Platform Evaluator. So we're going to test and validate this hardware platform to make sure it's good for real-time development. So if you go to the Start menu, All Programs, Interval Zero, RTX 2012, and under Tools, here's the Platform Evaluator. So we'll go ahead and open that. And here's the window, and just a brief tour. Up here in the upper left hand corner, we've got the measurement configuration. So here we're going to run actually two identical threads. So you can run one under Windows and then one under RTX as a comparison. So when you click the setup button, you can select what that is. Is it just going to be a thread switch latency we're going to measure, timer response, APIs? You can select what particular API you want to measure. Here you can select, as far as under the Windows side, what processor we want to run on. Remember, we only gave one to Windows, so you only have to select core 0 there. And then here is the RTX cores. So we're going to run the function on one of these cores. It really doesn't matter what we're going to do, but we'll go and select the 4th core or the 3rd real-time core. And we're going to want to measure timer response latency because many people are interested in that. So we'll go ahead and click OK. And so what this example is going to do is execute a 1 microsecond system tick, and we're going to measure the latencies. Okay, so here we can actually add loads. So here we're going to add a disk load, so you're going to see disk accesses, and we're also going to see some video as far as pop-ups, just to stress the video bus or the memory bus a little bit. Okay, and before we run, this is where you'll collect the data down below. So here's the Windows as far as responsiveness, as far as the mins and max, and here's the real-time or the RTX subsystem, and it's going to measure the timer response latencies there as well. And then here is where you're going to see the histogram information pop out. All right, so let's go ahead and hit run here, start. And you can see this is kind of a little busy here. We've got a lot of pop-ups stressing the video, but in a minute I'll pause it just so we can actually see what's going on and let it collect a little bit. All right, so let's hit stop. And you can see we've collected quite a bit of data, and here's the histogram. So it's hard to discern what's going on here, but this is essentially telling you the different responses. And the blue, a lot of that is the Windows side of things, and then the red is RTX. It's really hard to see, but this is just showing you here's in microseconds, you know, the responses, and here's a number of them. But here's really where you want to focus in on. So Windows, you can see the timer response latencies were pretty high. So we saw that the maximums were about 549 microseconds. So that's pretty long latency right there, as far as from when the timer interrupt occurred to when you're able to run software. If we look over here under RTX, you can see the average was about 1.9 as opposed to 84 with Windows. So 1.9 microseconds, and the worst case was 6 microseconds. It was the worst case. So you can see this is actually, you know, quite a good sound system for real-time development. This, of course, is going to be subjective, and it's up to you to decide whether or not this is going to be a good enough platform for you. But again, this tool is just to help you, you know, verify and make sure that you have a good system for real-time development with RTX.
Now that you've validated the hardware and software using the Platform Evaluator, we've completed all the steps necessary to validate all of the hardware and software so that you can do real-time development in RTX. Thank you.